In this video, I just want to provide one other way of looking at these hydrogen atom wave functions. So here, the sizes of the orbitals aren't emphasized as much, so we see that even the two, so we have NL and M listed here. So the n equals 2 and 3 and 4 orbitals are not scaled properly, right, as we saw in the previous versions. But this makes it a little bit easier to see what's going on with the angular nodes. So if we look at all of our s orbitals, so we have an s orbital here, 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 we can see there are no angular nodes, right? If you pick a specific angle, there's never a place where the wave function goes to 0, but there are radial nodes, as we saw, mathematically shown in the functions we looked at last time. So this is our 2s orbital. We can see the radial node here. 3s orbital, we see 2 radial nodes. 4s orbital, we see 3 radial nodes. 1, 2, 3. And when we look at the p orbitals, right, where L equals 1, so our 2 p orbitals are, we have 1 here, 2 here, and 3 here, our 3 different p orbitals. We can see they each have one radial node where the wave function goes, the probability distribution of the wave function goes to 0. Sorry, that's not a 2p orbital. It's not on here. Yeah, for some reason we skipped over the third 2p orbital. Right, but we can see very clearly these angular nodes. Sorry, these are called angular nodes. Got to keep these straight. That are showing up. Now, when we go to a 3p orbital, we get both. So when we look here at this 3p orbital, we see both an angular node right across the middle here, as well as at a specific radius. If we draw a circle, there's a node right there as well. And so this is, we get the same thing for this 3p orbital as well. And when we go to the d orbitals where L equals 2, now we'll see 2 angular nodes right here and here. So this is our 3d orbital here. And we have another 3d orbital here. So we see no radial nodes, but 2 angular nodes. And right, so you can see there's this pattern. And over our total number of nodes is equal to n minus 1. Right, so for a 1s orbital, there are 0 nodes. No angular, no radial nodes. And our number of radial nodes, sorry, I should say number of angular nodes is equal to L, right? So whatever our value of L is, that determines how many angular nodes we have. And so the number of radial nodes is simply the difference between those. So it's n minus L minus 1. And so that's an easy way to keep track of how many nodes a particular wave function should have.